Okay, so I decided to pull up this data set from R, the New York City Flights 13 thing. It's not like available in Python, so I exported it as a CSV, and I guess I'll upload that to CCLE. So let me do that, and you guys can try to follow along. And okay, well, anyway, while this is like loading up, so yeah, my encouragement to really kind of get a handle on this is just to play and practice and see what you can accomplish. Okay. Well, I don't know how much exploratory data analysis you've done in R itself, but whatever you've done in R, see if you can do the same in Python. With the New York City flights, it's like a simple enough data set that I think we can have in terms of like understanding what these columns mean and their things, like I think it's a pretty easy to pick up, and then we can just start asking questions, and then we can try to just hack at it and see if we can extract the answer that we want. It's and you'll find out, oh, you know what? It's kind of hard. So here, let me okay, so let me log in and get my Duo push. Success. All right, and then let me upload our New York City flights. I'll upload it as a zip because unzipped it's like 3.5 times as big. So it's still fairly sizable. Okay, and I think the data camp links on CCLE are working now. So I never got a reply, but it stopped giving me an error. So so that's good. Okay. All right, so anyway, we'll import our kind of standard things. I guess we don't need matplotlib right now. We'll just do numpy and pandas, and then we'll read in the data. All right, we'll just do pd for pandas, and then read._csv and your nycflights.csv. Okay, so you read that in, and then you ask, okay, let's take a look at the head, first 5 rows. Okay, and we see, this is data from 2013. We've got each month, each day. The departure time is funny, but it's there. And we'll notice that a lot of these things are stored as integers, except the departure time got turned into a float, and so did arrival time, arrival day, air time. So some of these things got turned into floats, even though in the original data file, if we were to open it up, we can see that everything in the original data file is appears as an integer, right? And so what this indicates to us is that if you see things that look like they're integers in the file, but then they got turned into floats, probably you have missing data, and Python doesn't have a missing data for integers, and so it upcasts the things to floats, so it can throw in an NaN in there. Okay, and so that's why we see departure time appearing as a float, And if we do departure.info, we can see departure time is a float, and some of these things are floats, okay? And basically, if we think about it, is that here we've got a bunch of flights that are scheduled, and then if a flight gets canceled, it's not going to have a departure time. And so when it gets, so the departure time is going to become NA, and then the arrival time will also become NA. And then so other things, such as how long it was delayed, will also have NAs, and the airtime will also be NA, and things like that, okay? So anyway, this is what the data looks like when we bring it in. You can use so here I said we're going to read it in, and then we're going to create a data frame, and we're just going to call the data frame df, okay? And then you can do df.head to see the first few rows, df.info to get info on each column, and it will tell you, okay, you've got 336,776 non-null values. And then as far as departure time and departure delay, we've got some, fewer 328,000 non-null values, and for whatever reason we have, I'm not quite sure why we have 521 with departure times and then even fewer with arrival times. I'm not entirely sure what the explanation there is, but anyway, that's, we've got some stuff. Okay. Let me cut that. Okay. You can ask for kind of the shape. It'll tell you how many rows, how many columns you have. And we can just do some very, very basic things. So we can take one of the columns, such as the origin column. Okay, and let me just kind of go through this. Okay, so if I just say df and then do bracket quote origin, this will print out the origin column, and then it will say you've got 336,000 rows. So we're not going to print everything. So it just kind of prints the top and it prints the end, and there you have it. Okay, and the origin column, this, you know what? Okay, let me restart my kernel. Restart and clear output. Okay, so we'll bring this in. We'll bring in our data set. We'll print this out, okay? And then right now, it's indexed just by integers, starting at 0, going to the n, okay? And then if I, again, there's my shape, I can just say, let's look at the origin. So these are all New York City flights, okay? And so we have, there's 3 airports in the New York area. There's EWR, which is Newark. It's technically in New Jersey, but it's in the New York City Greater Metro. LGA for LaGuardia and JFK Airport, okay? And we can ask, what are the unique values here, right? And then it tells you, okay, there's only three unique values. Okay. What I want to do is I want to use the date as an index here, okay? So right now we don't have any actual date time objects here. We do have the time and hour, and so this actually lends itself to be useful. But here I want to kind of show you, if you don't have that option, you can kind of concatenate some of these things together. Now, there's not, in dplyr, in R, there was like a function that did this for you. We don't have that, but we can kind of construct it ourselves, okay? So we can take each column, okay? So I can take the year, which looks like this, And if I scroll down here, it will say the data type here is an integer. Okay, but what I want to do is I want to concatenate this as a string type. So I'm going to do as type and type in str. Okay, and if I do that, it looks exactly the same, but now it will say dtype object, effectively a string here in this case. All right, and then now that I've got a string, I can tack on string things. So to get it into start to get to look like a date in kind of the ISO 8601 form, you know, you would have the 4-digit year, the month, and the day. So we're going to do this 2013, and then I'm going to add on basically our data frame will take the month column and do as type string, and then we'll add on another dash, and then we'll take the date column as type string, and then we'll did I do something wrong? Oh, I need a plus. Same mistake here. Okay, and that looks good. And then so basically I've taken this, and then I'm going to just store this into a column called date. All right, so by specifying df bracket date, this actually doesn't currently exist in our data frame. We have year, month, day, but there's no actual column for date. Okay, so I'm going to just throw this into date. Okay, and let's just take a look at the kind of the first 10 rows. Okay, and we can see all right, that looks good. And then there is a nice pandas function. So we use pandas.toDateTime, and we'll throw in that column. And before I save it into there, we can kind of see. And so right now, these are all strings. And when we do this, we can see it turns it into a DateTime object here, the D type. So I'll go ahead and I will store the results here into the date column. Okay. And then now if I ask for the info on this, okay, so currently I still have a range index, but I now have a column that shows that it's a DateTime object here. And I can set the index to this thing. So I'm going to just do df.setIndex to date, and then I'm going to replace our current data frame with this. So I'm going to say df is this. If I ask for the index, it will tell me you have this index here. The head now looks. Let's print the head of this. Okay. Okay, and we can see that the index is no longer 0, 1 through whatever, but it's now a date, the date column, which is good. And okay, so now so I've just changed the index here, and we can start trying to do some exploratory data analysis. And I just tried this out because it's been a while since I've done this, and I realized, you know, I've forgotten a lot of the vocabulary and the grammar and all of this. And it was a bit of a struggle. So this weekend I'm going to need to spend some time just kind of playing around with it. And I know you guys have midterms and all sorts of stuff to study for and do things. But you know, at some point over this quarter, you're going to have a final project. And really, what you got to do is you got to just sit down and just start trying to talk in Python, right? Just like when you learn a foreign language, you got to try to practice speaking it, and it's going to be clunky and awkward, and at the beginning no one will understand what you're trying to do, and Python's going to kick back errors, but then eventually you'll get to put the words together correctly and get it to do what you need to do. Okay, so one of the kind of the most important things is grouping and aggregating. You know, as far as you know, trying to do summaries here. So here I can do group by carrier, and it tells you, it just says the result here is a DataFrame group by object. And then if I say I'm going to group by carrier and then select one of the columns, then we get a series group by object. Okay, so these are both DataFrame and series things, but they also have group information in them. Okay, and so here I'm going to do group by carrier, and you know what, let's do the origins first. Okay, so we're going to group by the carrier, and then I'm going to select the origin column, and I'm going to apply the function unique. Okay, and so when I applied the function unique to the entire database, it gave me back, where did it go? It gave me back this. It just says there's EWR, LGA, JFK. Okay, that was when I applied it to the entire database. Okay, now I get pretty much the same thing, except it has been broken out by carrier. So AA is American and UA is United, and you know, I don't know what these other ones. DL is Delta, and I think WN is Southwest, but you know, I don't know what these other ones are. Okay, and so so these are some of these things, and we can see some of these airlines fly only to one of the airports. Okay, other airlines fly to all three, and some airlines only fly to two. Okay, I can also group by the destination and ask for unique values. Okay, and here we get kind of the listing, and so from here I can just say, all right, what about we'll ask for 9E. Okay, and this is kind of the list of all the unique values in that 9E flies to. And we can ask, whereas, okay, HA must be Hawaiian Airlines because they fly to Honolulu only. And you know, these other airlines, you know, some fly to a lot of destinations, and some only fly to a few, right? So I think VX must have been Virgin Airlines, the short-lived Virgin Airlines, who flew from LAX, San Francisco, Las Vegas. I don't know where these ones are, but pretty much like West Coast to East Coast only, and didn't go anywhere in between, type of thing. All right, and all of these things, you know, by doing a group by, you can also apply any kind of other aggregate functions. So if you wanted to do, instead of the destination, we can do a count of departure times. Okay. And so if we grouped by the origin, so not by the carrier this time. So here we're only going to get 3. And here we said group by the origin, look at the column departure time, and just count. Okay. And so here we can see Newark has about, I don't know, 117,000. JFK has about 109,000. And LaGuardia has about 101,000. So they're all comparable in terms of how busy they are. Okay. And then as far as but keep in mind the departure time has NAs, whereas the destination column, or just, you know, scheduled departure time or whatever it might be, some of the other columns do not have NAs. All right, and so the counts will end up slightly different for each of these things. Okay. And but again, you know, we see kind of the same pattern. Newark being having the most, JFK a little bit somewhere in the middle, and LaGuardia having the least, but all kind of on an order. They're not like orders of magnitude separating them, maybe about 15%, 16% difference between the busiest and the least busy airport in the New York area. Okay, you know, those are counts. We could, if we wanted to, we could take one of the numeric columns. So we could do kind of departure delay. That's a numeric column, and we can do departure delay and ask for the mean. Okay, and these are the mean amount of time each origin is delayed. Okay, so also LaGuardia has the least amount of delay, but you know, and we can also ask for the median, and the median delay is actually ahead of schedule. So over 50% of flights depart on time or a little bit over. It's just every now and then you're going to have this extremely delayed flight, and that drags out the mean, right? So so we have this, and so much like dplyr, you have the group by function, and you know, you can group it by anything you want. So you can say on what month. Okay, so December, you know, let's see which month had the greatest. Apparently June and July. Okay, so so you can do that. You can ask, you know, how many flights went to LAX. So we can just ask the column, you know, df destination equal to LAX, and that will give us true and false, a Boolean thing. And so if we just want to know how many went to LA, you can just do sum, and we get something like this: about 16,000 flights over the year from New York, the New York area to LA. Okay. If you wanted to just look at flights that went to LA, you can subset the entire data frame itself, and you can just do df and then a single square bracket, and then you provide it basically the that Boolean vector or Boolean series, and the result will be a data frame LAX underscore df that that now only has flights going to Los Angeles. Okay, and we can take a look at the head here, and we can see, all right, we've got all these flights, and the destination for all of these is LAX. Okay. And then if we want to see, okay, if we group by origin, we can see how many go, and what we notice is that there's actually most of the flights from New York to LA come from JFK. Some of them come from Newark, and none come from LaGuardia. Okay, so that's, at least that was the case in 2013. I don't know if it's still the same or not. Flying to from LaGuardia to LA was not possible back then. Okay, we can also take a look, you know, grouping by, so you can summarize via count. You can ask for the mean or the median, and so here we're going to ask for you know, group by the origin, you know, whether coming from Newark or JFK. On average, what's the departure delay, and again, and you can group by a different variable here. Carriers, so we've got American Airlines, Delta, United, Virgin, B6. What flight carrier is B6? B6 is JetBlue. Okay. All right. So apparently these were These were the ones that appeared in our data set here, okay? And see here, I've grouped by origin, I've grouped by carrier. You can also provide it 2 levels of group by. You can provide it a compound grouping. Okay, so I've got group by, and then inside there I give it a list of the columns that I want it to group by. We can group by carrier and origin, and then we'll look at the departure delays and ask it to summarize there. Okay, and so for American Airlines, we apparently they fly out of Newark and JFK, and these are the mean departure delays. JetBlue only flew from JFK, Delta only flies from JFK, but United and VX, I'm assuming VX is Virgin, but maybe it's not. Yeah, VX was Virgin America. What airline is VX? Look at that. Virgin America. Okay. Are they still around? No, right? Okay. I don't fly very much, but okay. So anyway, that's what we have. All right. If we wanted to do so this is where I discovered, like, I forgot how to do a lot of this stuff here. Okay. So here I wanted to group by date, and I'm going to and I wanted to so this is what I was trying to do, and I realized this was quite hard. So I did mean, and I got this, and then I wanted to sort it. And so I tried to do sort values ascending equals false. Oh, and it worked. Okay, never mind. I don't know what I was trying to do then. Okay, so so here, I grouped by the date, and we're looking at the departure delay. This is for everybody, and we want to see, on what days was the mean departure delay the greatest, and this is what we have, and we can ask for just the head here, and I don't know if there's anything special about these days. July 1, September, July 1, July 10th, September 2nd, March 3rd, or March 8th. I don't know. Okay. I don't know why I was having trouble with it. Okay. All right. And then, I just started asking more questions, right? So what if we wanted to just look at days where there were, or just the flights that were delayed? Okay, so here I did, what we want to do is departure delay is greater than 0, okay? And so this will give me back if the flight was delayed, not, and then I'm going to subset the data frame based on this, okay? So here I'm going to get basically a data frame. So rather than trying to store intermediate results, and with Python we don't exactly have pipes, but you kind of just end up creating new objects after you subsort these things. Okay, so here we can see on info we had 128,000 flights have been delayed. Okay, and all right, what was the thing I want to do? Is I want to see how many on what days do we have just the most count, not just the greatest amount of time, but just the greatest number of flights that were delayed, right? So here, maybe I'll put in the question that I want to ask for each of these. Okay, on what days was the departure delay the largest on average? Okay, All right, over here, we're going to ask, on what days did we have the greatest number of departure delays? We'll just say of delayed flights. Okay, so I was going to do group by date. Okay, so now, parentheses. Okay, so got my our syntax in mind here. Okay, so we want to group by the date, and then and let's just count up departure delay. Okay, so let's do departure delay and just do a count here. Okay, so here this lists off every single day and counts up how many flights were delayed. And then let's do sort values, ascending equals false, and let's just print out the head here. Okay. So on December 23rd, we had 674 delayed flights. Something must have happened on March 8th and July 1. I don't know what happened, but we had a bunch of delayed flights on those days as well. But so maybe there was a storm. I don't know. March 8th, I have no idea. Okay. December 23rd, that kind of makes sense, right? Just high holiday travel. So things happen. Okay. All right, and then I was curious, you know, what if I looked at each month and each carrier and just wanted to see how many flights were delayed, okay? And so so for this, I subset our data frame to just those that had delayed flights. So I said subset the data frame such that I'll kind of just write each of these things out. Subset the data frame to rows where departure delay is greater than 0. Okay, so basically delayed flights. And then we're going to group by month and carrier. Okay, and then we select the departure delay column. We count those. And then unstack. So if I didn't have unstack, this would just give me this. It would say for the month of January, these are the carriers that we have, and these are how many flights were delayed. Okay, and then it would do this for all 12 months. Unstacking them says, well, you know what? Each month kind of has similar values, and so we can spread them out into kind of this two-way table. So this is effective. This is a pivot table, okay? And we could achieve the same table by using pivot, okay? And so if I wanted to just get, and then so these are the number of flights for each month and each carrier that were delayed. Oops, let's print this. Now unstack. Okay, so that's And then if I wanted to just get the full count, number of flights by month, number of flights total by month and carrier, then the only difference between this one, this command here, and this command here is that over here I just subset the entire data frame by this condition. I said departure delay has to be greater than 0, meaning it's a delayed flight. Whereas over here I just have the data frame itself. Okay, so the command is pretty much exactly the same, and so we can see, okay, American Airlines had 904 flights that were delayed in January out of a total of 2,735 flights. Okay. The same thing, this same table can be achieved using the pivot table function. Okay, and so here I take the data frame and the pivot table, and then I think the default ordering is values, index, and columns, but you can send them in out of order. So here the index will be the month, the columns will be the carrier, and the values that go inside here will be departure time. But we're not just taking each one, but we're going to aggregate them using the count function. Okay, and so we can see that the results here for when we did the group by, the aggregate, and the unstack, and then using the pivot table, we get the same results. I don't know if that's visible. Yeah. Question.
Are they like literally the same objects?
No, they are not. They are not the same objects. So if I do type here, well, I don't know, maybe. So here I get a data frame. Get the same. Are they? Oh, is there a? What's the identical function? Python identical. Check if all elements in a list are. I think, yeah, the array equal will probably be the same, but well, I don't know. Okay. But just a quick visual check, we can see we're getting the same numbers across the board here. Okay, and then thus, if we want to ask, what proportion of flights were delayed each month for each carrier, we can do basically this top table. Okay, but I wrote it in pivot table form. And so I have, pivot table, month, columns, values, or month, carrier, departure time, aggregate function count, divided by, and then down here, same thing, okay? And because they're going to have the same dimensions, it will do element-wise division. This slash is for the division. This slash means I'm going to write on the next line, okay? So in Python, if you don't put an indicator that you're going to write on the next line, it's going to complain. It will say you ended this line and you should have an argument there, and I didn't see anything. So you got to say, all right, the backslash for I'm continuing to write on the next line, and we do this and we get a bunch of numbers, and we see, okay, basically in January, on the order of 30% of flights are delayed, and in December, well, I don't know. It looks different. So maybe we just want to we don't want to do this by month, but let's just aggregate. We want to just know which months have the greatest proportion of delays. So we can just departure delay group by, we'll say month. And then the only difference here is we're not I think this will do it. Okay. All right. So if you don't want to be delayed, September, only 28% of flights are delayed. In December, about half of flights are delayed. Same in June and July. June and July, you've got almost half, and then the other months you're hovering around. So September, October, November, only about 30% of flights are delayed. The other months around 35 to 40% of flights are delayed, and then the summer and Christmas, December month, you're almost half of flights are delayed. So I don't know. Okay, so you know, as we go on, we can just have as you're exploring the data set, you just keep asking, like, you know, what's an interesting question, and see if you can kind of hack through the data frame and get the answer that you want. I don't know. What would be an interesting question to ask? Ask now. I guess we can ask, instead of grouping by month, we can just group by carrier and just see overall which carriers have the greatest proportion of delays. Here, and then, so if we ask the type on this entire thing, it will tell us it's a series. So I'm going to just take this whole thing and I'm going to ask for sort values, and we'll say ascending equals false. Okay. All right. And the greatest number of delays was WN, and the least was HA, Hawaiian Airlines. So WN, I think, is, what airline is WN? I think that's Southwest. Yeah, Southwest. Okay. But, you know, this, keep in mind, the departure delay we just said is greater than 0. But maybe we're like, okay, departure delay greater than 10. Okay. And then when we say, okay, who is late by more than 10 minutes in terms of departing, it's carrier F9. I don't know what that is. What airline is F9? Frontier Airlines. Okay. And maybe we were like, I don't care about departure delay. What I'm actually curious is arrival delay. All right. Let's see what we get. Okay. So as far as being late by over 10 minutes, Frontier Airlines F9, 43% of their flights are late by more than 10 minutes. And an FL, what's FL? AirTran. Well, that's no surprise. All right. So like the bargain airlines, right? Frontier and AirTran, for whatever reason. And, you know, maybe it's like we'll ask about 20-minute things that are over 20. Yes, same thing holds. Okay. So Hawaiian Airlines has the, you know, fewest number of arrival delays that are over 20 minutes delayed, and things of that nature. Okay. I don't know. So all of these, so you can subset the entire data frame just by doing df and then bracket, and you put in some kind of conditional filter, and this will just take the entire data frame and produce another data frame with just a fewer number of rows or whatever, and then you can aggregate them accordingly, group by carrier, and count them up, or whatever it might be, and do some kind of analysis. And so I know school is getting is picking up in pace for everybody, but my recommendation, again, the only way you get better in speaking the language is by practice speaking it, and the only way you're going to get better at handling data frames and stuff in Python is by trying it out on the computer. And so I encourage you to just take kind of an open-ended data set and just say, like, all right, what can I find? And just ask questions, and you know, come up with questions that you can say, all right, this is what I want to do. I want to find count how many rows belong to this, and divide by you know, how many rows over here or something like that. If you can think of it in your head in terms of what you want it to do, you can probably think of what you should be doing in terms of the code, and it's just a matter of finding the right words and putting together the correct structure here. Okay, you'll notice this when you make when you write something, it can get to a point where it's quite complex, right? Like if I just threw this at you and I said try to parse this out, it's probably not too easy. But all of these things have been built up. Okay, we started off by filtering out the data frame to just have the rows that we want. From there, we applied some kind of aggregate function like counting them up using the group by. Okay, and then to get a proportion. And then once you get a resulting series, then you can apply something like sort and things like that. Okay. All right, we'll just end there for now. We won't have a quiz on Monday. We'll push the quiz to Wednesday, okay? And then, but it'll be a pandas quiz, and yeah, I'll try to keep it on the easier side about about things, okay? I don't know. I guess I said that about the NumPy thing, and people weren't too happy about that. So, you know, we'll see what happens. Okay. All right. Good luck.